to cover. Okay, and myself, Madhukant Sharma, and I'm going to teach you the probability part, and then Professor Gagan will take over. Of course, I think uh, after the mid-semester exam, uh, uh, and he's going to complete the statistics and information theory part. Okay, and today's lecture will be mainly focused on to cover up, or you can say, brush up the things which are essentially required to address the probability concept. Okay, namely as you can say basic counting principles and set theory, permutation and combination. With means we will try to address them uh, with few examples and try to cover up the things as much as possible. Okay, right. So this before going to that, I may also address that assessment part, or before that you have the text and reference books, which I'm going to follow is the second one, Probability and Statistics for Engineers and Scientists by Sheldon Ross. It's fourth edition, and it is available in Library Resource Center. Okay, so you can get an online access. I hope it is available for online access as well, and you can work out the problems there as well. and of course the tutorials will be there for helping you in solving the problems by associated TAs. One of us will try to be there because it's a very large class. So sometime it's like it is for a single person, it is not possible to address each one doubt. So whenever if it is remain somewhere, suppose you have not got a doubt you're clear, so you are always welcome to put it on email. Okay, it's a very common practice, and so if you are at campus we would have met and could have discussed, but unfortunately it's online mode. So you can anytime reach us and with your doubts. Okay, and of course you should prefer first this group discussion among yourself. Means by any means, means like you can conduct your Google meeting on Google Meets and all. Okay, it's freely available, I think, for all the students as well. You can conduct the Google Meet. Okay, and you can join group discussion there. Of course, you can reach our associated TAs. I think soon the list of the TAs will be also out, and you can, of course, you can throw your doubts to them, and suppose it is still remains unclear. Okay, of course, you can reach us as well to clear your doubts. Okay, right. So then I want to say at the very first class regarding the assessment method, there will be two examinations: mid-semester examination and end semester examination for this course. And we are not going to take help of metal. We are going to conduct it on Moodle. Okay, so it is, you can say, it is necessary for you to join the Moodle, okay, as soon as possible. Okay, and do practice there. So we will see how we can train you to, I don't know, because I don't have an idea that whether how much you are familiar with Moodle and how to. There will be like quiz. We will conduct some of the quizzes, and you will get a help in help in writing your examination and all. Okay, we will try to do that. Okay, so yes, percentage of the mid semester examination and end semester examination, how we will distribute uh, is going to be at 30-70%. Okay, so mid semester examination will contribute 30%, and end semester examination will contribute 70%. Okay, yeah, and of course mid semester examination will be fully focused on probability. End semester examination will cover up complete syllabus. Okay, so that's the main thing which I wanted to address. Assessment method. Now another thing is regarding the supplying of materials, lecture materials or lecture videos and all. Okay, so of course I will post the lecture one slides on Moodle. You have to keep update yourself with Moodle. Okay, also I will post the link of the lecture video on the Moodle. Okay, and that you can access, and means the link will be only active, only available for a certain period. It will be only public for certain period. It is on YouTube channel. You can search for my name, Madhukant Sharma, YouTube channel. So it will be public only for number of, means like fixed number of days. Okay, that I will see is either a week or a maximum up to 15 days. Okay, so you have to make your notes and all, whatever you want to do. Okay, how to learn, how many times you want to watch and all. Okay, right, and also you will get the tutorial sheets. Okay, which you have to solve. Okay, don't expect us to give us the solution, detailed solution. Okay, you have to solve the problem. If you are finding any difficulty, okay, then you can of course reach us. I think first you can go through the group discussion, then secondly you can go to the TAs, and then you can reach us. But doesn't mean that you cannot directly reach us. Of course you are welcome to reach us anytime. Okay, but it will be preferable process. Okay, right. So I think that's it. I can tell you about this at present about regarding this course structure, how we are going to conduct and how we are going to evaluate, how we will supply the lecture material to all of you. Okay, right. So without any delay, I will start the lecture. Okay, let me do that. Yes. So am I audible? Yeah, you are able to see the screen. Yeah, fine. Okay. So okay, so I'm going to start with the lecture now. Okay, which is mainly focused on the review of some selected mathematical techniques. Okay, right. Before getting to our main business, we will try to review quickly some of the selected techniques which are very basics to understand for this. Be able to hear this video? That video I'm playing, is it audible to all of you? Okay.
Probability course. Okay. Such as basic counting principles, and there are permutation combination, and at the end that sets. You all are familiar with all these three things. Okay. So we are going to work out some number of examples based on these topics, so that your basics will brush up here. Okay. And if you have any query or any doubt at any place, so please raise your hand, put your comments or put your doubt in your chat box, and try to address it. Okay, so basic counting principles, computation, combination, offsets, so that we are going to done. So let's take.
So you are not able to hear the video, right? No, I am audible, but whether video is audible? Okay, but myself, just a second.
Okay. So the example is as follows. It's a small community consisting of men, and each of whom has two children. So if one woman and one of her children are to be chosen as mother and child of the year, how many different choices are possible? So if you denote each woman by W1, W2, and on W12, so each W1 is followed by either C1 into C2. Similarly, so C1, C2 are her children. So you can combine W1, C1, W2, C2. W2C1, W2C2, and so on. So there are how many number of different now choices are possible is each woman has two. So 1 into 2 plus 1 into 2 plus 1 into 2 and so on 12 times. So that is going to be 12 into 2. So there are number of possible different choices are 24. Okay. So similarly, let's try to, so these are simultaneous tasks here. So that's why here, so product rule. Okay. So 1 into 2 plus 1 into 2 plus 1 into 2 and so on. Okay. Right. So that's why here product and sum rule are both are placed here. Okay. Right. Let's have one more, another question here. Suppose a person has 3 shirts and 5 ties. How many ways he can choose a shirt with a tie? So he want to go in a party. Okay. So he will look into the mirror. How many number of possible? So you can denote shirts are like S1, S2, S3. So each has 5 choices. One, two, three, four, five. Okay, you can name them T1, T2, T3, T4, T5 by ties. So 1 into 5. So, right? So that's 1 into 5 plus 1 into 5 plus 1 into 5. So there are 3 into 5. There are total number of, you can choose a shirt with a tie T. Okay, right. So what is happening is here is simultaneous task is happening. Okay, so instead of this 1 into 5, 1 into 5, you can simply go with the 3 into 5 because 3 are alike and 5 are alike. Okay, so but you are going to choose out of them only one from a like one. So 3 from 3 shirt, you are going to choose one, and 5 tie, you are going to choose one. So you are going to match it. So there are going to be 3C1 into 5C1. That's going to be 50. Okay, right. So what this rule says is, suppose two experiments E1 and E2 are to be performed in order or simultaneously. So the simultaneous task means immediately after that. Okay, so with N1 possible outcomes for E1 and N2 possible outcomes for E2, then together there are how many number of possible outcomes of two experiments are going to be N1 into N2. So you can go back and check for the first example we were having. So two experiments from women, that's W, and E2 is your children, number of children. So N1 possible outcomes. So 12 possible women are there, 12 women were there, and 2 children were there. So then together there were 12 into 2, that is 24. Similarly, for the next case, 3 shirts with 5 ties. Okay, right. So that's going to be, that answer is 50. So this can be certainly generalized to not, this is not only limited to 2 tasks.
Yes, am I here? I'm here. Okay. Yeah, am I audible? Yeah, skin is visible. Okay. Yeah, so let's start with this live lecture. Okay, at least for today, I will try to you'll see in the next time. Okay, so we have, as mentioned, we are going to try to recall the few of the important things which are very necessary for talking about the probability definition. Okay, and further it will be also used in statistics. Okay, right. So uh, as I told, this we are going to cover up basic counting principle, permutation and combination, and algebra of sets. Okay, right. So I hope this example is clear to all. So let's read this example and try to address the solution very quickly. I will not spend much time over it. So the example states that you take a small community which consists of 12 women, each of whom has 2 children. Okay, so let's name those women as W1, W2, W12, and childs with W1, C1, C2, and 2 children. So we can name them. So okay, so if one woman and one of our children are to be chosen as mother and child of the year, how many different choices are possible? So it's very obvious to uh, sum up all the possible cases here. So suppose you focus on this W1. W1 has 2 choices. So you have the pair W1C1 and W2C2, W1C2. So each one has 2 possibilities. Okay. Similarly, the next one is also has 2 possibility, and so on. The last one also have 2 possibilities. Okay. And so you have this plus and so on. Okay. So that will be how many times is going to be 12 into 2. So what I want you to understand from this example is there are 2 cases. One case is simultaneously happening. Okay, so you have one woman, you can't leave, means like you need to choose a woman as well as her children as a pair. Okay, so W1, if you choose W1, it has to be chosen with either with C1 or with C2. Okay, similarly W2, either choose with C1 or C2 and so on. Okay, so there are total number of cases is, so it's 1 into 2. So you have choices. So each one has 2 choices. So 1 into 2 plus 1 into 2 and so on plus 1 into 2. So total 12 cases are there. Okay, right. So here, this is why here is a sum rule. Okay, so that's going to be, I think, 24. Okay, right. Now let's go to the next example. That suppose a person wants to go for a party and he has the choice of 3 shirts and 5 ties. How many ways he can choose a shirt with a tie? Okay, so I think you can answer yourself. Okay, very quickly. Okay, so you have 3 shirts and 5 ties. So each shirt have 5 choices. Okay, each shirt have 5 choices. So how many? So each shirt have 5 choices. So 1 into 5, or 1 plus 1 plus 1 plus 1 plus 5, 5 times, plus 1 into 5 plus 1 into 5, that's going to be 3 into 5, that's going to be 15. I think these questions are very simple to understand. Okay, right. Now what is happening here is the product rule. You have seen this 12 into 2, you have seen 3 into 5. Okay, so you have here is the somewhere product rule is applicable. Why? So you have here is the some statement is that supposed to experiments E1 and E2 are to be formed in order or simultaneously. Okay, and E1 has N1 possible outcomes and E2 has N2 number of possible outcomes. Okay, so like you have to means like if you focus on this example, you have the women and children. Okay, in this case you have shirts and another is ties. Okay, so N1 possible outcomes for E1 and N2 possible outcomes for E2. So 2 children, 12 women, right? So each woman has going to 12 into 2. So this going here is the N1 is possible outcome. So out of women, there are 12 number of women. Each woman has 2 children. So this is why here, if you make it, this is E1 and this is E2. Okay. So then together there are how many choices is N1 into N2. Now, this is not restricted with the only 2 experiments. You can extend it to any finite number of experiments. Okay, so what do you mean? It's as follows. You have this, suppose you have n experiments are to be performed in order of simultaneously. So with possible number of outcomes n1 to nn respectively. Then how many together there are possible outcomes are n1 into n2 into and so on. So here is the simultaneously happening. So this is why here is the product rule. Okay, right. Now let's take this example here. It's not okay. Right. Okay. So you have this how many 8 place license plates are possible if first 4 places are to be occupied by alphabets and last 4 by numbers. Okay. So you have 8 places on the license plate. So if you have a license plate, okay, if you have the license plate, you have 8 number of places, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay. Now, how many 8 place license plates are possible if first 4 places are to be occupied by alphabets and last 4 by numbers? So you have first 4 places by alphabets and last 4 places by numbers. So how many choices is you have here? You can fix any alphabet from A to Z. Okay, and you can fix any number between 0 to 9. Okay, so now it is not given here that you cannot have the case like A. You can't. I mean, there's no. I mean, it's like it is not saying that repetition is not allowed. Okay, so all possible things, whatever you want to do, you can do. But the first 4 places should be identified with any alphabet, and last 4 places should be identified by any number. Okay, 0 to 9. Okay, so first 4 places have, each one has 26 choices, right? So this has 26 choices, this also has 26 choices, this also has 26 choices, this also has 26 choices. You can, each one you can identify as E1, E2, E3, E4, E5, E6, E7, E8. Okay, you can name them as experiments. And how many possible outcomes? So first 4 places have possible outcomes are 26, 26, 26. Now this last 4 places, now I hope it's now you can say it, this has, each has 10 choices, right? So total number of choices we have, these are simultaneous because you cannot create a license plate without filling any place. Okay, so this is simultaneous task again. So it's going to be 26 into 26 into 26 into 26 into 10 into 10 into 10. Okay, So that you can find out when like 26 to the power 4 into 10 to the power. Okay, right. Now let's move to the next example. Suppose repetition of letters and numbers is not permitted. Okay, suppose repetition of letters and numbers is not permitted. Okay, means this case is not possible. The first, so you can certainly have now, if you want to create a plate with 8 places, 1 2 3 4 5 6 7 8. Now first, that is so sure that you have to first 4 places should be occupied by alphabet and last 4 places with by numbers. Okay, so but repetition of alphabet or repetition of number is not allowed. So first place will have 26 choices. Now second place, since one of the alphabet is already used, so the next place cannot use that. Okay, so one is left, so you have next place has the choices is 25. Similarly, the next place has the choice is 24, and then you have the place is 23. Similarly, for this case is 10, 9, possible outcomes 8 and 7. So you can multiply all of them and you will get the final answer. Okay, so this is a repetition of letters and number is not permitted. Okay, right. Now let's move to this problem. So consider a collection of 3 novels by authors A, B and C. So there are 3 authors. Name them as A, B, C, who wrote novels. Okay, then 2 mathematics books by authors D and E, and 1 physics book by author B. So you have 5 authors, right? A, B, C, D, E, and okay, 6 authors E. Now these are novels writer. Okay, these are mathematicians, you can say, and this is by physicists. Now how many arrangements are possible? It's asking you how many arrangements are possible if the books are to be distinguished by the authors. Okay, so how many arrangements are possible if the books are to be distinguished by the author? So it doesn't matter whether first novel, second math and third physics. Only you have to distinguish by the author. Okay, so how many? So you have total 6 places. 1, 2, 3, 4, 5, 6 places need to be filled in a cell, you can say. Now first place can either be novel, can either be math, can either be physics. Okay, or you can say either one of them, A, B, C, D, E, P. So first place had choice 6 number of choices. Of course, you don't have means authors means like you cannot because see, once here author A is fixed, it will not come to this next place or third place or fifth, fourth place or fifth place or sixth place. So there is no possibility of repetition. Okay, so the second place has how many choices now? Suppose this has come here. How many choices? 1, 2, 3, 4, 5. So total 5 choices. Again, once one of them has come here, if you have placed one of them here, now the next will have 4. Similarly, 3, 2, and 1. So if you do all, so these are simultaneous, that's going to be 6 into 5 into 4 into 3 into 2, 1. I think you are very familiar with this notation, 6 factorial, and that is total is going to be 720. Okay. Now, so this is the case when you are distinguishing the books by the authors. Suppose you are distinguishing the books by the subjects. What will happen? Okay, means the novels, if novels are sitting, so novels are sitting together, maths books are sitting together, physics books are sitting together. It's like in a library cell. You go in the library and you match differential equations, topic wise, the books are self together. Okay, and you can say some of the physics books are together, and so on. So if this happens, what will be the case? Now, so there are three subjects, right? Novels, maths, and physics. Okay, so let's have, so you are not distinguishing by the authors, you are distinguishing by the novels, math, and physics, by the subjects. Okay, now, so you have six places, 1, 2, 3, 4, 5, and 6. Now, suppose your particular case, so let's take first novel, then math, then physics. Okay, so if novel first comes, so how many possible ways? So this is the first 3 choices, second one has 2 choice, then you have first 1 choice. Now for the math case, if you are going to next, this is going to be how many choices? 2, this is going to be 1, and this is going to be physics. Okay, it's going to be 1. So you have, this is 3 factorial into 2 factorial into 1. So this is a particular case when you have novel first, mathematics second, and then physics third. So how many total possible this? Is going to be again 3 factorial. Okay, so these are how many ways you can handle them? 3 factorial ways. So this should be multiplied by 3 factorial. So this is going to be 6 into 6 into 2. So it's going to be 70. So possible number of arrangements are possible, are 72 possible arrangements if the books are to be distinguished by the subjects. Okay, right. Now, this is the answer for the next question. Okay, right. Now, let's quickly talk about this permutation and combination. So, if the order is important, so number of arrangements of an object is n factorial. Okay, it's very simple to observe, right? First place has out of n objects. Okay, first place has n choices, second place has n minus 1 choices, third place has n minus 2 choices, and so on. Okay, so how many ways you can arrange is n factorial. Okay, now if the order is not important, for example, means if you can take an example of like recently this like Olympic is or some tennis is going on, right? So there are players, okay, from different countries. So you can put them, Indians are alike, Australians are alike. Means you are not distinguishing with respect to their games. You are only distinguishing with respect to country. Okay, so there are number of alike peoples. You can name them. Okay, similar. Okay, so number of arrangements of n objects where n1 are alike, n2 are alike, and so on, n are alike, means you have out of n objects you have, so there are this many, n1 are alike, n2 are alike, so you can make them different categories out of that are objects. Okay, Indians, Australians, South Africans, Sri Lankans, and so on. Okay, out of n objects. Means you have total number of them is n. Okay, so that is given by the formula n factorial divided by n1 factorial. I have to remove these many things. Okay, right. I am not going to much detail for this part. Okay, right. So let's take one example. I think answer is given here, but don't focus on here. Okay, so a tennis tournament has 9 competitors, 3 from India, 2 from Japan, and 4 from Australia. So results of the tournament are announced by nationalities of the player. So it's very clear now, nationalities here. So Indians are, you can make as let's take N1. So 3 are Indians, okay, 2 are Japanese, and 4 are Australian, in which they are placed. How many such lists are possible? Okay, so okay, here order is not important. Okay, so total numbers are how many? 3 are alike, 2 are alike, and 4 are alike. So that's going to be 9. So total possible arrangements are going to be 9 factorial divided by 3 factorial into 2 factorial into 4 factorial. And that's going to be counted as 1260. Okay, right. Now the situation will be different when you are not announcing the results with respect to the nationalities. Okay, right. Now the question is, in a collection of n objects, in how many ways can we select R objects? Means I hope means like you are very familiar with NCR and NPR. Okay, right. So let's try to answer that. So you have can we see how many ways can we select R objects? So there are various things. So first thing is repetition is allowed. Okay, so you have R places 1, 2, 3, 4, 5, and so on till R places. Okay, so how many ways can we select R objects? So repetition is allowed, means each one has n choices, n into n into and so on, n to the power R. And repetition is not allowed. Okay, so you have, this is first place has n choice, and repetition is not allowed. And you have first place has n choice, second place has n minus 1 choice, third place has n minus 2 choice, and so on. Rth place has how many choices? Is n minus r plus 1. Right? And if you try to write down in terms of factorials, this is nothing but if you complete it, what is remaining is n minus r to 1. So n factorial divided by n minus r factorial. Right? Right? So you are just multiplying by n minus r to 1. So but that is nothing but the 1. So when the repetition is not allowed, you have this. So this is we are going to note, no, the notation is here permutation. Okay, right. If the order is important. Okay, right. Now if the order is immaterial, okay, if the order is immaterial, how many are alike there? Then r and n minus r. Okay, so you have again, if you go back and check here, n minus r are alike and n are alike, you can go back and match with that result. Okay, so this will generate the formula. If the order is immaterial, you have this. So each place, okay, you how many ways is n choose r. So out of n, you can choose any of the r. Okay, So this is the formula. You can see, right, r plus n minus r is n, if you can recall, if you can connect that result, previous result. Okay, right. Now let's take the this question, that a jury of 7 people is to be formed from a group of 30 people. How many different juries can be formed? One of the answer here is written, so I don't want to go with this. I will add something here. Okay, so a jury of 7 members is to be formed from a group of 30 people. So let's have 30 people should be divided. So let's take up 10 women and 20 men. Okay, and now how many different juries can be formed? So if I ask you this question straightforward, so that's the answer is 37, because order here I have not mentioned anything else, that this many number of women should be there or this many number of men should be there. Okay, so still the answer will be the same, 37. Okay, out of 30 people you can choose any 7 people. Now suppose I do add the condition that is you have you can say 10 out of 10 you can say 4 women and 7 men, sorry, 3 men. Then what will be the answer? Can you guess? 7 jury members is to be formed, and let's take the condition that out of 7 members, 4 women and 3 men. Yeah, so out of 10, any woman can come, right? So order is immaterial. If you name it as like W1, W2, W3, Wn, and so on, W10, doesn't matter. Out of 10, any 4 you can choose. So 10 choose 4. Now since the jury has not been formed so far, so it's a simultaneous task, so this why here multiplication. And out of 20 men, you can choose anyone, any 3 of them. Okay, so that will answer your question. So that you can simplify. Okay, more. Okay, right. So this this answered in different ways. So you have 2 women and 5 men. So 10 C2 into 20 C5. That's fine. Okay, right. Okay, now let's move to the set theory. Okay, so I hope you have studied already the set theory in your previous sessions, maybe during your real analysis or complex analysis or somewhere in calculus, okay, or in +2 level. Okay, so the very first thing is set is a collection of well-defined objects, which we name as called elements. So it has a means this word has a significant impact here. So well-definedness is necessary. Okay, for example, at present you are 285 students, means participants at present. Number of participants are 285. Now, if I let's take, suppose I say I'm going to take a collection of good participants. How do I justify that? It's a very challengeable thing. It's not a well-defined thing. Or suppose I take the participants which has above 7 CPI. Let's have some well-defined. Okay, or means like 6.5 CPI or something. I will maintain the criteria. Then it will make sense. So I will say these are good when you have 6.5 CPI above. Okay, or if I say in general, in population, let's take the collection of all fathers. It's not well defined. Okay, right. So, so you have to be this understanding of set definition. So this must be clarity about the objects. Okay, with certain parameters, so that well-definedness can be addressed. Okay, right. Now the very basic things we can recall here. Okay, the like subsets, proper subsets, equality of two sets, union of two sets, intersection of two sets, De Morgan's law, distributive law. Let's quickly review them. Okay, so let's have, this is a very famous notation, omega. If you familiar with it, it's a mathematical notation of, okay, various things. Okay, not only restricted with the abstract or universal set. Sometimes it has the notation as like, I think in a +2 standard I studied that U is a standard universal set. Anyway, you can fix any one of them, it doesn't matter. Okay, now it's very clear when we say a set is a subset of other. Okay, suppose, so if every element of A lies inside B, you will say A is a subset of B. And if you are able to identify an element of B which is not a member of A, you will say A is a proper subset. So very simple example which you can recall is a set of natural number and set of real numbers. So set of natural number is a subset of, proper subset of set of real numbers. Indeed, it's a proper subset of set of integers, right? Okay, so I have taken R is a very bigger set. Set of natural number is a bigger is a subset of set of integers. Set of natural numbers is a subset, a proper subset of set of integers. Okay, so in other words, you will say B is a superset of A and so on. Now, when we say two sets are equal, if every elements of A lies inside B and every elements of B lies inside A, means either both ways, if it is true, means A subset of B and B is a subset of A. If you can prove that, you can say that both are equal. Okay, please note there is a major difference between equality and equivalent. Okay, there is a major difference between equality of two sets and equivalent sets. Okay, when we say two sets are equivalent, when you have the number of objects are the same in the both the sets. Okay, or if you have heard this name like cardinality of the set, okay, means you have n number of objects in A and B also has a n number of objects, then you can always define a 1-1 onto correspondence between them. So that is the definition of equivalent sets. Okay, so here only we are restricted with the equality, we are not going anywhere else. Okay, right, so it's very clear. Now complement, I hope it's very clear. So A is a subset of omega, universal set, and if you collect all the possible elements in omega which are not the part of A, that is known as the A complement. It's very clear. Okay, union will collect, means if you take any two of the sets, it will collect all the possible elements from each one of them. Okay, so you will collect the elements from A as well as on B, and you make them together, that is known as union of the two sets. In some of the cases, it's also known as sum. Okay, right. Now, intersection is you are trying to visualize that what is common between those two sets. If I give you two sets, okay, you will try to identify what is the common between them. Actual, you can say. For example, set of natural number again and set of integers. So if you try to take the intersection, you will get the set of natural number itself. Right? Okay? Okay. Now, so this is a very famous notation phi, which is the notation for null set, or you can say empty set. Okay? Right. And two sets we say disjoint if their intersection is empty. Okay? For example, set of natural number and set of negative integers. Okay? So these are disjoint sets. Or we will sometime will also say mutually exclusive sets. Okay? Right. Now, De Morgan's law, and it can be visualized through Venn diagram. Okay? So De Morgan's law says that you take the union of two sets and take their complement. That is equal to the sets. You take the complement of A, take the complement of B, and find out their common part. Okay, this is what the De Morgan's law says. Okay, the second one also will be the case. So if you try to understand it by Venn diagram, it's very simple. Okay, so you have two sets A, you have another set is B. Okay, I hope okay, this is A and this is B, and I hope you can name this is a nothing but the A intersection. Okay, which is common between them. Okay, now if you this is what you want is A union B complement. Okay, so A union B is this complete one. A and B together, A and B and B. And what is A union B complement is, this is everything. Okay. Now, if you try to identify A complement and B complement from this graph, okay, it's very simple. So A complement is this, right? Try to distinguish, okay. You can also draw in your pen and paper, okay. And B complement is somewhere like, okay, this is B complement. And if you try to find the intersection, you will find only these red lines. Okay, so this proves the De Morgan's law. Similarly, for other part A intersection B complement, you can prove that A intersection B complement is A complement union B complement. That's fine. Okay. Now the next result, what here is known as distributive law. Okay, distributive law. So the first one is left distributive, right? So yeah, or distribution of union over the intersection. The second part is intersection distribution over the union. Okay, so you can distribute. So you have here very clear. that also you can try to verify through the Venn diagram. Okay, I'm not going to draw here. It's very simple. Okay, so you can distribute union inside and then take the intersection. So for the first case, you take, so A union B intersection C is same as you take union with B, A union with C, and then take the intersection. Similarly for the next case. Okay, right. Now, okay, so now we can start now talking about probability. Okay, so the very first definition for talking about the probability is conducting an experiment. So there are possibly two type of experiments. One is deterministic, another is indeterministic experiment. And we are going to focus on indeterministic experiment hereafter. Deterministic experiment, you can understand, it's like you have a bag, you put all the white balls or you put all the red balls inside. All the balls are red, suppose. And suppose somebody asks you, what is the chance that you have a red ball in your bag? It's clear deterministic. Sure, you're certainly sure that this is red. You can answer that. And suppose somebody asks you, what is the chance that there is a white ball? You are also still sure. Okay, means there is no white ball, means chance is 0. Okay, there is a red ball, chance is certain, that's 1. Okay, now if you mix up some of the colors, okay, suppose you know in the bag there are red balls, there are white balls, there are green balls. So, okay, now if I put the hand inside your bag, what is the chance that I will get white ball? This is an indeterministic experiment. Though you know there is a white ball, I have told you white, red and green. Okay, so there is a chance that either I will get white or I will get red or I will get green. Any one of them. But not sure about it. Okay, so this is an example of indeterministic experiment. Okay, so here if you read out all these 3 points here, you will get a very clear definition of a random X. So that's why it's here name is attached is random, is a randomness. Okay, so the first point says that the set of all possible outcomes of the experiment is known in advance. Means you know at prior that inside your bag there are color of balls are red, green and white. How many numbers? Suppose there are 5, 4, 3. You can fix the numbers as well. Okay, so suppose in your bag 5 white plus 6 green plus 4 blue. Okay, now when you draw a ball from your bag, so this you are conducting an experiment. So the outcome of a particular trial means particular trial means either you are picking up 2 balls or 1 balls or 3 balls at a time. Okay, that's a fixed trial. Okay, but the outcome cannot be predicted in advance. Okay, the third point is the experiment can be repeated under identical conditions. This is very important. Okay, so if you want to repeat the particular trial again, it should be repeated in the identical conditions, and it's very clear by the name itself, identical conditions. Means you are at the same room, at the same place, okay, and you are fair in all means. Okay, there is no biasness with respect to the conditions and so on. Okay, so that experiment is called random experiment. And the first statement, the set of all possible outcomes, if you write it down, the set of all possible outcomes, and I will denote it by again omega, and that will be called as sample space. Okay, and if you draw, or if you are conducting an experiment and that particular trial means drawn 2 balls, 3 balls, 5 balls, and so on. Okay, that we will denote as a, this is nothing but the subset of this omega, which is called as event. Okay, particular trial could be all of the balls you are drawing. Okay, or you are try to draw 2 balls, 3 balls, 5 balls. Okay, so this is a definition of event and sample space. Okay, now we are going to try to attach the definition of probability with this. As I told you, so deterministic environment only have binary things, either 0 or 1. Okay, either you are sure means sure event, means that certainly will happen, the chance is sure, certainly, and certainty is identified by 1. Okay, and you are also sure that there is no such type of balls, that's going to be means like impossible event, that's going to be 0. Okay, so any number between, so the range of the probability, if you identify this probability as a function, the range will be lies on into the set of interval is 0, 1. So probability is going to be a function which associates the sample space, okay, every element of the sample space to a number between 0 to 1. With certainly some definition is also will come into the picture. Okay, that so probability of E is lies between 0 to 1. Okay, that's so sure. Okay, right. So I think okay, I think we can stop here for today's class. Okay, fine, and we will try to continue in this manner. Okay, hereafter. Fine. Okay. Thank you. But of course, you will get the recording of that that video. Okay. You can access that on the YouTube.